Heidi-ho there, neighbor. Got a little practice problem for you, but I'm not sure. Oh, wait, there it went. Okay, so what we're going to do, you can just say thank you, Mr. Krause, right now. This is only for those of you that are motivated to do well on tomorrow's test. So what I decided to do is take you through a few problems that I think you might have issues with tomorrow, see how you do with them, and maybe it'll help you, maybe it won't. Okay, so we're going to go through these quickly. I would expect that if you really want to do this, I'll probably post, if I don't post this, I'm going to try to post this as a PDF, this document. There's only a few questions, a couple pages, but only a couple questions. And I'll try to post it as a PDF and then download it, print it if you can. If you can't, then just do the problems on your own separate sheet of paper and then see how you do. Hopefully this helps you with the test. If it doesn't, well, it should. It should. So let's get started. First things first. As usual, we're going to put parentheses around this. Again, my computer is acting up, so we'll see how we do. So what we want to do is we want to make sure that these two things are the same. They have to be exactly the same. Right now they're not. Because if they were the same, we just have to set the exponents equal to each other. So what we're going to do is we're going to conform this 4 and make it 2 squared. We're going to conform this 8 and make it 2 cubed. Now I'm going to bring this off to the side here. So what I have here is 2 squared times 2x squared plus x minus 6 equals 3x squared plus 1. Well, now that I have the bases the same, all I got to do is set the exponents equal to each other. Set these two things equal to each other. Okay, so 4x squared, you're probably wondering where I got that. I'm distributing the 2, plus 2x minus 12 equals 3x squared plus 3. Now it's a quadratic that needs to be solved, so everything's going to the left side. So I'm going to subtract off 3x squared, and I'm going to subtract, this is a plus 3. So I'm going to subtract 3. So I get x squared plus 2x minus 15 equals 0. Factor it, x plus 5, x minus 3 equals 0, and I get two answers. I get x equals negative 5 and x equals 3. You should get in a habit of checking these. So we're going to store one. What do we say? Negative 5, control var x. And we're going to do 4 raised to the 2x squared plus x minus 6. See what I get? Whoa, holy crap. All right, let's try the other one. 8 raised to the x squared plus 1. Well, whatever that number is, it looks like it might be correct. Because look at it, all the same. And then if I do the same thing with 3 stow x, these should work as well. Hit the up arrow, bing, hit that one. That's a little bit more of a reasonable number. It looks more like my salary. The other one looked like, I don't know, everybody's salary. And then those two work. So that's an easy way to check. All right. So here's the directions. The directions say expand. We're going to expand this thing out. Now in your brain, you're going to take one logarithm. You're going to take one logarithm here, and we're going to turn it into 1, 2, 3 logarithms. In between here we have multiplication, and in between here we have division. So when I split these two up, they're going to make addition, and this is going to give me subtraction. So I'm going to start with log base 2. Again, if you forget this 2, you're going to be in trouble, of x squared plus log of base 2 of y minus log base 2 of z. Now you have to remember that this square root really has an exponent that's a 1/2. So this is z to the 1/2. Now, the other thing you got to remember to do is exponents can't stay here. They need to slide out front. So 2, and we'll get rid of it here. And then this 1/2 slides out front here, becomes 1/2, and we'll get rid of it here. And that would be the answer. So think about it. Break it down. Oh, yeah, we got 1, 2, 3. So that's going to, when I expand it, that's 3 logs. 1 log, 2 log, 3 log. And think about addition and subtraction. Now we're going to condense. So now I've got 1 log, 2 logs, 3 logs. I'm going to condense that down to 1 log. Now, first things first, return exponents. Now, if I return that one, whoa, there should be a b here. Sorry, I didn't write it down. I return that one, that 1/2 goes here, and this one doesn't have an exponent. So in between here is going to be multiplication. Multiplication. And in between here is going to be division. So it's going to be this thing divided by this thing. So this becomes log base 5 division. The only thing that's going in the top is this a squared. And in the bottom, we're going to have the square root of b, and then it's times c, so I'll just put the c out front. It doesn't matter if it goes front. There it is. Don't forget to write that base. It's all about that base. So here, you got to be able to go back and forth. The question is solve for x. So I want to get x by itself. It's already in log form. So if it's in log form, you convert it to exponential form. And when you do that, say in your head, it's all about that base, There's the base, 5. Now, this was the exponent. This thing's now going to go over here, and this thing comes over here. They switch. So 5 squared is equal to 7x minus 17. Add the 17 over. Of course, that's 25 plus 17. So I get 42. That's 25 plus 17 equals 7x. So x equals 6. Ka-ching. All right, this next one says, solve algebraically for x, round to the thousands place. Well, you're not going to have to be able to do the whole thing algebraically, but you do need to show how you got your work. So the first thing I got to do is I got to get the weird thing alone. In this case, the weird thing is all of this. This is the weird thing. So I got to get that weird thing alone, which means I got to get rid of the 5. So I'm going to divide by 5, and I'm going to divide by 5. So what I have here is 3.2 to the x is equal to 9/5. Now that I have it in exponential form, I can convert it to log form. It's all about that base. So I'm going to change it to log. Base goes down here, 3.2, make sure it's at the bottom. And then these two things switch. Of 9/5 is equal to x. So I go to my calculator, control log 3.2 of 9 divided by 5, and I get 0.505. And I think it said round to the thousands place. So over here, 0.505. Uh-oh. Okay, so x equals 0.505. I wasn't able to change. Oh, something crap was happening down here. So here we're going to solve this problem, but what I need to do is I first need to condense this into 1 log. So I'm going to take 2 logs and I'm going to condense it into 1 log. So log, now it's base 10, I don't have to put that there, but maybe that makes you feel better, of x minus 3, x plus 5, is equal to log base 10 of 33. Well, here's that weird case where you have 1 log equal to another log. So if this thing in yellow was, let's say, a big pizza, and this thing was a big pizza, they would be equal. It's log of a yellow box equals log of a yellow box. So what do I have to do? I just have to set those yellow boxes equal to each other, and I'll do that over here. X minus 3 times x plus 5 has to equal 33. Well, this is x squared plus 2x minus 15 equals 33. We'll subtract off the 33. I get x squared plus 2x minus 48 equals 0. I factor it. X plus 8. X minus 6 equals negative 8. And x equals positive 6. all answers must be checked. And if you were to plug this -8 in either here or in here, it would crash because you would be taking the log of a negative number, and you're not allowed to do that. So the only answer in this case is 6. The only answer is 6. The -8 has to be canceled off. We just get rid of that. All right. So I want to solve for x. Now this question's not as easy as this one here, because this one already had log by itself. Down here, I've got 2 logs. I got a log here and I got a log here. So the first thing I got to do is condense these suckers. So I'm going to condense them. Oops, I got to return the 2. So I get log base 2 of x minus 2 squared. Now wait, that turns into division. So divided by 4 equals 3. So now I've condensed it from 2 logs to 1 log. Now we're going to change its form and make it exponential. And it's all about that base, So 2 is the base. And then these 2 things switch sides. So 2 cubed is equal to x minus 2 squared, which is just x minus 2 times x minus 2. So 8 is equal to x squared minus 4x plus 4. Subtract 8. I get 0 is equal to x squared minus 4x minus 4. And I think I forgot to put in the directions on this one. They should have said round your answer to the nearest decimal. So what I would do with this one is, did I do something wrong here? Oh, I did something wrong. What am I doing? I'm sorry. I did something wrong. So let me start over. The base part was right. So it still should say round to the nearest thousands or round to thousands place. So what I just made a mistake. So it's 2 cubed is equal to x minus 2 squared over 4. I just forgot the over 4. So what I have here is 8 over 1 equals x minus 2 squared over 4. We're going to cross multiply. Ka-ching, ka-ching. So I get x minus 2 times x minus 2 equals 32. X squared minus 4x plus 4 equals 32. And you get x minus 4x plus 4 equals, oops, excuse me, I forgot to subtract 32. So subtract 32 from both sides, and we get, so we're subtracting 32, bringing it over, and I get minus 28. Well, that does not factor. So what I would do is use completing the square. You could use the quadratic formula. I'll show you the quadratic formula. And then I'm going to show you completing the square. So let me use the quadratic formula. A is 1, B is negative 4, C is negative 28, and D is equal to 16. That's B squared minus 4 times A, which is 1, times B, which is negative 28. So this, I believe, is 128, but let me see. 16 minus 4 times 1 times negative 28, 128. So D is equal to 128. So I come over here and I say, okay, x is equal to negative B, 4, over 2 times 1, plus or minus the square root of 128 over 2 times 1. Now, I don't have to simplify this. At this point right now, I said to the nearest thousand. I just grab my calculator. So I do, I forgot what that was, 4 over 2. So that's just 2, plus the square root of 128 divided by 2. 7.6568. 7.6568. And I said to the thousandths place, so this one is x equals 7.657. And then the other one would be the same exact thing, except we'll just do a minus. And I get negative 3.65. X equals negative 3.65. 685, about the same thing, right? Oh, the other one was 685 too. 7.65685. Okay, 65685. So x equals negative 3.657. But you have to check these. And if I go back and check these, I would find out that this negative 3, when I put it in here, if I put in that negative 3 here, point whatever, it would cause problems here, and that would be undefined. So that doesn't work. What I also could have done is completing the square, and it would have been much easier because I could have done it back here. When I cross multiply here, won't I get x minus 2 squared equals 32? Sure. Now, if I want to, at this point, I just take the square root of both sides. Square root, put a plus or minus. So I get x minus 2 equals plus or minus the square root of 32. Again, I said round to the thousandths place, so you don't have to simplify. It's x equals 2 plus or minus the square root of 32. And you'll find out that these are the same thing. 2 plus the square root of 32. It's going to be equal to that same 7.65, and then change the plus to a minus, and you get that negative 3.65. So it would have been easier just to do this. All right, moving on. Almost done. What is the inverse? Okay, inverse. Well, it's a log. In order to solve a log, you have to do its inverse, which is an exponential function. It's all about the base. So 3, now this was the exponent. These two switch. 3 to the x is equal to y. Done. Okay. When is a logarithm undefined? A logarithm is undefined when you try to take the log of 0 or anything negative. You can't take the log of 0 and you can't take the log of anything negative. Well, here is the log. Not the 10. The 10 has nothing to do with it. So what values can this not be? This can't be 0 or anything less than. So I can represent that in two ways. I can represent it as x cannot equal less than or equal to 0. It asks for when it's undefined. It's undefined when x is less than or equal to 0 or negative infinity to 0, including 0. Now let's look at this problem. This problem's a little bit different. This one says, when is this thing undefined? Well, now this whole thing is the logarithm. So what value here would make this undefined? X equals 3. So when is it undefined? When x is less than or equal to 3. All right, kind of tricky questions. Let's read through this one. I think you already did. Hopefully you already had. In the year 2004, get my highlighter out. In the year 2004, we're going to invest $1,000 at 3.5% interest. And we're going to use this formula, and we're going to do it quarterly. All right. So let's see what we got. We got our initial amount P equal to 1,000. Our R equal to 3.5%. We'll talk about that in a second. And our N, because it's quarterly, is equal to 4. So we're going to use our formula. Y equals 1,000 plus, or times 1 plus. Now, some of you are going to have a hard time with this rate. So let's pretend this doesn't exist. And you're just going to do 3%. Well, 3% is 0.03, and then I bring that back. Oh, yeah, 0.035 over n, which is 4. raised to the 4t, nt, 4t. So now the question says, how much money will I have in 10 years? Well, we're just going to plug 10 in here. So it's y equals 1,000, 1 plus 0.035 divided by 4 raised to the 4 times 10. All right. So 1,000 parentheses 1 plus control division 0.035 over 4 raised to the 4 times 10. And we're going to have $1,416. So y equals $1,416.91. It's money, round to money. You shouldn't ask me where I'm going to round to. It's money, round to money. There it is. Now, the second half of this problem is a little bit trickier. The second half of this problem says, in what year will your money be doubled? Well, if I start with $1,000 and I want to double my money, that means I'm going to have $2,000. So let's take a look. We're going to use the same formula, but it's much harder. So we're going to bring this over here. We're going to draw. So now I want to end up with $2,000. My formula is 1,000 times 1 plus 0.035 over 4 to the 4t. In this case, I'm now looking for t. Well, you have to isolate the weird thing, and in this case, the weird thing is this base and its exponent. So we're going to isolate that by moving the 1,000 over. Well, that's pretty simple. We just divide both sides by 1,000. So I get 2 is equal to 1 plus 0.035 over 4 to the 4t. And yeah, you could have typed that in your calculator, but it gives you almost as much of an obnoxious number. A lot of the kids don't like looking at this number on this side. They think it looks a little bit better when it's over here. So I'm just going to move it over there. Same thing. So now we have an exponential. In order to solve an exponential, we have to use, whenever to solve an exponential, you have to change the base. So it's all about that base. So you're going to do, we have an exponential, we're going to use log of, this is the base, 1 plus 0.035 over 4 of, and then these two things switch, 2 equals 4 times t. Well, I still don't have t by itself, so I'm going to divide by 4 and divide by 4. So that obnoxious thing needs to get put in your calculator. It's not too bad. Let me clean up a little bit so you can see it. So log of parentheses 1 plus 0.035 divided by 4. You'll see that looks nice when it's done. Of 2. Does it look the same? Yep, there's the base. So 79 years, but don't forget we still have to divide by 4. So divided by 4, and I get 19.89 years. So t is equal to 19.89 years. But I don't believe that's what was asked. The question says, in what year? Well, I started in 2004. I came up with 19.89 years. So to this 19.89 years, I'm going to add 2004. And I say, oh, lo and behold, in the year 2023, right here, in the year 2023, I know it rounds to 2024, but in the year 2023, my money will have doubled. So the answer is 2023. All right, I did one more of these just because I want to do one of them quarterly. But I could use quarterly, and this next one I use, I don't even know, monthly maybe. So here's the next problem. In the year 2010, you invested $1,500 in an aggressive mutual fund. They promised you that they would compound your interest monthly. Oh, I forgot to tell you the rate. At a rate of 5.6%. I don't know, 5.6%. All right, so this is my initial amount. This is my interest rate. It's monthly, so n is equal to 12. Now I'm ready to write my equation. So it said P of t, I believe. P of t is equal to, I don't even remember what I was starting with, $1,500. 1 plus my rate. Now, if this part wasn't here and it was just 5%, I would write 0.05, but it's 5.6, so I got to put the 6 at the end. 12 months to the 12t. So there's my generic equation that I'm going to use for both of these problems. In problem 1 says, how much money would I have at the beginning of 2020? If I take 2020 and I subtract off 2010, that means 10 years has passed. Oh, I didn't mean for that to happen. So I'm going to plug a 10 in here. So go to my calculator, and I go 1,000, 1,000, parentheses, 1 plus 0.056 divided by 12 raised to the 12 times 10. $1,748, so $1,748.39. There it is. Next question says, in what year would you have $4,000? So we're going to use the same formula, but in this case, we're going to put 4,000 on the left equals 1,500. 1 plus 0.056 over 12 to the 12 times t. And now we're looking for t. So we got to get the weird thing alone. The first thing we're going to do is divide by 1,500. And we're going to cast out these zeros because we don't need them. So I end up with, and I'm going to write it the way you like it, 1 plus 0.056 over 12 to the 12t is equal to 40 over 15. Now we're going to change its form. We're going to change the form. It's in exponential. Now we're going to go logarithmic. So log. Now remember, this thing right here is the base. And then these two are going to switch. So log of 1 plus 0.056 over 12 of 40 over 15 is equal to 12t. Divide by 12, divide by 12. So let's see. So log 1 plus 0.056 divided by 12 of 40 divided by 15. Now remember, I want to take a look at this. 1 plus this, 40 over 15. So 210.66 is out. Now I can't round yet because I still have to divide by 12. So don't round yet. Divide by 12. And you get 17.556 years. So t is equal to 17.556 years. And again, what year did we start? We started in 2010. So I'm going to take this and I'm going to add 2010, and the year would be 2027 and about halfway through. So in the year 2027, I or you would have $4,000. That's it, kids. All right, just a little bit more review. I hope you enjoyed it. I hope you did it. I hope it makes sense to you. All right. Well, thanks for coming to the party, kids. Goodbye.